We have a lot to say today. I hope we are going to have a nice, interesting talk. I prepared about 90 slides for today's talk. This is a huge, huge, huge topic, a very broad topic. And I'm afraid 3, 4 hours, not even two winter or summer schools would be enough to discuss all of the possibilities here available to us. But I will try to do my best to provide an overview for you guys and do this to the best of my abilities. Having said that, I would like to start with a little bit about what SODAS is and where I come from. So my background, as Dr. Sumeia's background, is also in political science. I got my PhD from the University of Lisbon, and somewhere around my second to third year of my PhD, I took a turn for the computational. I just started learning about programming, about R, about Python, in order to tackle some of the tasks of my project. And that put me on a path towards doing more computational stuff. Then my postdoc led me to some other positions, including a position into a data lab that the social sciences school, the Faculty of Social Sciences at the University of Copenhagen had, where we assisted researchers with any computational aspect of their research and projects, from assistance with programming to other stuff. And unfortunately, that infrastructure closed. But I'm happy to have this assistant professor position right now at the Center for Social Data Science, SODAS. So SODAS is a pretty big, relatively speaking, interdisciplinary a team of academics with a multitude of backgrounds. So you might find there people that come from political all over the social sciences spectrum, political science, economics, psychology, etc. But also some very technical backgrounds also there. And the idea of this department is that we try to bring together social sciences with data science practices, with computational practices that are very, very developed in other fields, but not so much in ours. And most importantly, we are trying to bring the social aspect into what is data science today, right? It's something super important and not so easy to do. We have our master's program in social data science, where we invite applicants from both backgrounds, so either only social science backgrounds or only technical backgrounds. And then the first would learn to incorporate computational practices into their social science background, and those with the technical background are learning how to infuse social science aspects, theoretical aspects, core aspects of social science into their data and technical backgrounds. There are a couple of research projects right now running. Pretty high level research is taking place. Very briefly, just for the sake of doing this introduction, but I'm happy to share more if you have questions about this. But by the way, throughout this talk, you are more than welcome to ask questions while I talk. But at the end of every section of our talk today, we're going to have also like a dedicated Q&A. But you're more than welcome to raise your hand. I'm going to do my best to monitor the screen, but also Dr. Sumeia, if you have a chance to see someone's question. Also, everyone, please feel free to also turn on your mic, interrupt me. I'm more than happy to answer any question on the fly. So what I was saying is that there's a lot of really cool research taking place right now at SODAS, especially at the intersection of AI, in research, science of science. So a pretty cool project right now running by Professor Roberta Sinatra, who's won an ERC grant on quantifying AI-infused science. So how much of our scientific work is infused right now by AI. And she's answering questions like, how can AI generate scientific writing that is systematically similar to that created by humans? How is knowledge connected compared to how it was before? How do humans relate to AI-generated science? And generally pretty interesting stuff. Additionally, many people are working on biases, on how algorithms, whether and how algorithms are fair, and models, large language models that we're going to be talking about, how fair they are, what biases they have in different languages, in different cultures. Again, very interesting stuff. We also do stuff like data sprints, where professors like Yevgeny Golovchenko here on the right side of the screen, they had about 1 terabyte of public vessel ships geolocation data that they got access to. They gave the data to the students of the master's program and PhD students for about 9 hours, and they allowed them to play with the data, explore the data, try to reach interesting conclusions about the data. And then they also wrote a report that you can also find, and again, a very interesting way to get the students engaged, play with data, get examples of how you can work with data that can actually also produce certain scientific outputs that could be interesting for their careers, of course. So with that being said about sodas, let me tell you what I would like to do today, what I plan to do today. I plan to give you a general intro to what AI is, what LLMs are, especially in research. We're going to see about the limitations. I think we are entering a phase right now where people are understanding those limitations a bit better. And the hype potentially about AI in general is maybe slowing down a little bit. We're getting a reality check, let's say. We are going to speak about what alternatives are out there to ChatGPT or other models. We're going to talk about open proprietary models, local LLMs that you can run on your machine. Pretty cool stuff. Then we're going to take a break, and we're going to come back and speak about the whole process of doing academic research and how AI has infused that, and that includes a literature review. I'm going to speak about a really phenomenal tool called Elicit that helps a lot with the initial stages of a literature review. And then we're going to speak about data collection and analysis, both qualitative stuff and quantitative stuff, things like transcription, automated annotation of data, etc. Then after another break, we're going to enter the third session. And there I'm going to be talking about academic writing, scientific publishing, general text editing with AI tools about academic writing specifically. Also something about publication, image generation, stuff like that. And then finally, I'm gonna wrap this off. Hopefully, you're not gonna be extremely tired at the end of this. And we're gonna speak about the ethics of AI, something light. We're gonna just have a slowed down version of the ethics of using AI in academia in general. I hope that is clear. Before we start, I need to make a huge disclaimer here. By the way, I see there's almost 100 participants in the call. That's extremely nice. Congratulations for making everyone attend. That's great. I hope this is going to be the attendance next in 2-3 weeks in the winter school. That's great. So yeah. A big disclaimer is warranted here at this stage, and this disclaimer is threefold. So one is that whatever we're going to say here today and the tools we're going to see and the things we're going to speak about are things that are developing in an extremely fast pace, right? Anything related to AI right now is moving with the speed of light practically. Many things are developing, many companies are entering the game, and providing new tools. So it's extremely important to understand that what we are talking about today is definitely working today, but we cannot make any guarantees that this is going to be the tool, the process for not even the next half a year. So you need, I mean, certain things are universal, but certain other things are not. And academics need to be aware of this, need to be aware of where they are investing their time, energy, and efforts, and make sure that that they are keeping track of what has become obsolete, what is new out there. And this is not always easy, right? I mean, certain things are a bit we cannot be on our toes all the time, monitoring what new advances are coming. So hopefully, projects like YADESA or similar would also invest in monitoring and providing accumulated information for researchers as to what is up to date and what isn't. Yeah, also another disclaimer is that what I'm telling you today is to the best of my knowledge. It's my understanding of AI for research. It's by all means not at all definitive. You might have much more brilliant ideas, about how to use some of these tools for your research. It can be a very creative process too. So please don't take this as the way to do things. This is not, it's not the case whatsoever. So with the disclaimer out of the way, I'm sure that most of you guys have seen a couple of things on YouTube and elsewhere about how to use ChatGPT, how to use AI, about a million things, especially making money. Many people are making a lot of this about how you can become rich with using a ChatGPT only, which is great, or not. There's also a lot of material online about how AI and AI tools and LLMs can also be used in research. Some of this stuff is really nice. Some of this is really snake oil. It's like it's useless. It's not working at all. It's mostly promising, riding the wave of the hype instead of actually doing a service to the science. So hopefully one of the things we can do today is also helping you navigate this super large landscape of what is available out there. So I would like to start with something very simple today, which is a question about what is ChatGPT anyway? Uh, if you don't mind, I would like you to scan this QR code and go to a Slido deck where we can all answer a very small question. So if you don't mind scanning this QR code with your phones, it would be great. I'll give you a minute to do so. And while we're doing that, I'm also gonna go there. So I hope you can still see this and scan it. So if you go there now, like those that are already there and don't see anything, please refresh it once. You should be able to see something like this right now. And I would like you to answer this question. So to what extent do you currently use AI and LLM tools in your daily research tasks? So yeah, 5 is always, 1 is not at all. I'm gonna give you some time to go to do this. Okay, we have about 50 votes. Just giving a little bit more time. But it looks like the group today is leaning towards the often to always. So 40% of you guys have said around 4. So it means that you're already using AI and LLM tools quite a bit. There's like 23, 24% now that uses it always. That's great. And there's also, though, 2% to 4% of you guys that are either not using it at all or using it very little. So that's also very, very interesting. So having heard your average use of tools, of AI tools and LLM tools, if you want, you can refresh now Slido and try to ask this question. Try to answer this question. So refresh Slido, and now this question should be available for you. So when you ask an AI chatbot like ChatGPT a question, what is actually doing? Okay, I see that at least nobody is selecting the having a human in the background write an answer. That's good. All right, about 50 of you voted already. That's great. So it looks like the winning answer right now is the first. So is using algorithms to select a response from a list of filtered options from a database. Also, the answer accessing the internet in real time to find the best answer has gotten almost a third of the votes. And 25% of you guys, about one quarter, answered that ChatGPT is guessing what words should come next based on patterns it learned. Well, I would like to tell you that none of the 4 answers is exactly correct. It's just that there is one of those that is a bit less wrong than the others, and that's this one. So guessing what words should come next based on patterns it learned. So ChatGPT or any LLM is actually not using algorithms to select a response from a list of filtered options. It doesn't have answers ready-made in a database that is picking from. It is actually guessing words one by one that should follow the thing that we are asking it. And it does so based on patterns it learned, but so this is an oversimplification, obviously, and it's not exactly right. So with that in mind, and thank you for participating with your votes, it's really nice. I'd like to go back and try to explain a little bit about what ChatGPT, because you see, you use AI and LLM a lot as you answered, but you are not, so let's go back to this. You are not actually 100% sure about what is going under the hood. So that's one of the important things here, right? It's understanding what we are using, understanding the tools we're using and how they're working. So that would allow us to use them more efficiently, but also would make us very aware of the caveats that are out there, right, when we're using this model. So what is a model exactly doing when we're asking it a question? So going back to the question about what is ChatGPT anyway, I just wanted to, and I know this is going to be familiar with some of you, but just bear with me for a couple of slides because I think this is extremely important. So ChatGPT is basically a conversational artificial intelligence model. It's a chatbot, like the ones we had before when we entered a website of a company that was extremely slow and answered in the same way all the time. That was not helpful at all. But it's just based now on some much more advanced technology, conversational technology and architecture that comes from machine learning. And ChatGPT in particular has been developed, the technology has been developed by OpenAI, a company that is behind ChatGPT. And obviously you are majority of you guys have already opened ChatGPT before, and you know there's a screen like this where you type a message, you hit enter. It takes a few moments, and then it starts producing a response to you that looks phenomenally like a human is responding to you, which is almost close to magical, right? But the technology, as we said, generative pre-trained transformer, GPT, which is in the name, is just a family of natural language processing models. Natural language processing is a computational field of its own, and these models have been around. Large language models and this transformer family of them has been around for quite a bit of time. So from 2017, actually, it's just that OpenAI using ChatGPT and introducing ChatGPT revolutionized the way that simple people like me and you guys that are not machine learning experts, programming gurus, allowed us to interact with an LLM in a super easy way. And that's what revolutionized this. And that's why we're having this conversation today. It's just because one company decided to make this front end thing where you just type a message, hit enter, and you move on. Very briefly again, there are three characteristics in these large language models. So one is the word large, which is massive scale. So these models have been trained on an enormous amount of data in the majority of them, consisting of billions of words from multiple resources. So most of them have scraped the entire internet sometimes, and they have the data from the entire internet. The second thing is the transformer architecture, as we said, from 2017, and that's the language part. They can learn grammar, facts, word knowledge, and generally the cool thing about it is that they can understand how humans use language. And by understand, we don't mean that they actually understand how we are using it. It's just that they've seen so many instances of us using the words and the combinations of words and the order of words that they can now learn the patterns that they've seen. And they can calculate probabilities about what's more probable to follow one word after another, just because they've seen so many pairs or larger than just pairs of words. Then finally, a key characteristic is this idea of, and I'm sure we're going to see that in the winter school in a couple of weeks, is that there's unsupervised pre-training and fine-tuning. So these models are pre-trained on an enormous amount of data, but then after pre-training, these LLMs have the capacity to be trained, fine-tuned, so tuned for a fine aspect of something, so they can be retrained on more specific data sets, more specific objectives, and that makes them very capable on tackling very specific tasks as well, especially smaller versions of these very large models, which can be very useful also for people doing research. And we're going to see about that too. Here on the side, there are a couple of important building blocks when we're talking about LLMs. And if someone is actually interested about learning what's happening under the hood, they should be familiar with all this. There's also a really nice. I mean, there are a bunch of YouTube videos about what LLMs are and how they work. And I suggest you do some research and find. But I also have I have some recommendations. So if you would like, you're more than welcome to send me an email about this. I'm also going to share all of these slides with Dr. Sumey, and you're more than welcome to share this with the participants. I'm super happy with that. So moving on. Another important thing is that the model does not actually predict words only. Although we simplify it like that, it actually produces tokens. And that's something super crucial for all of us being in the same level of understanding here for the majority of the tasks that we will do, especially on day 6 what we will do with using LLMs to do some research tasks, okay? So tokens are not words. So the model does not understand words particularly. So when you feed it a sentence like this one, like I love programming, it's awesome, these are 2 sentences, the model, in order to digest this and make meaning of this, and then try to answer the question that you might have been asking here, it needs to make chunks of this text. So in order to do that, it does that by tokenizing this sentence, by creating tokens. And in this case, we have 7 tokens. I is a token, love is a token, programming is a token, but also the full stop is a token itself. Sometimes words are split as well. So programming is 1 word, but it could be split into 2 tokens in other cases. So in these 2 sentences, we have 7 tokens, for example. And this is what is fed to an LLM. And it tries to understand this based on its own understanding of all these tokens and how many times it has seen the word programming in multiple sentences and tries to understand it. We also have really helpful tools like OpenAI's tokenizer. So at platform.openai/tokenizer, I can input a sentence. So I can do the same thing. I love programming. It's awesome. And then it will create the tokenization so that you can see how a sentence is tokenized. I know this doesn't sound extremely intuitive at this stage, but I really want you to keep this because we're going to be using it a lot. It's extremely important. Right. So back to the slides. So tokenization, right? That's the first step. So a model takes a sentence, it splits it into chunks, and then it passes it on to its database to try to produce. And the average model has more than 100,000 tokens, and it chooses after you've sent your prompt, it calculates what is the most probable word out of its 100,000 of tokens that should follow what you started typing. And it looks something like this. I'm going to play that again one more time. So what is happening here is that a model does not pick an answer from a database of answers, does not search the web. The model does not know what it's going to tell you the moment it starts producing the answer. What is happening is a model sees what you typed. So in this case, if you could see the underlying probability distributions a large language model uses when generating text, comma, then, after the word then, it takes all of its tokens and calculates probabilities like the ones below of what of the words that has in its list is most probable that is following the word then. In this case, it calculated that the word you was the most probable, and it put that word there. Then based on the next sentence, it calculated that would be the next most probable word, then essentially, then be, and etc. Until it reached this model word, and it calculated that the full stop, the token of full stop, is 89% probable that it follows this, this word after it has seen the rest of the sentence, right? So what is super key here to understand is that an LLM has no idea what they are about to generate or say the moment you start typing a sentence. This is extremely key. So a model is not like a magical thing that works and acts like a human. It just starts generating word by word, trying to based on probabilities of what they've seen before, how many times they've seen, that the word idea follows the word no, and it produces this sentence. It doesn't know the full sentence is going to send, not even the next word that is going to produce. And that's very, very, very key. I hope that this is clear. But if there's any question at this point, please let me know. I'm not going to bother you too much about technical aspects anymore. From now on, we're just going to hype this up, what's cool and what's available about LLMs. But if there is any question, I'm more than happy to hear you out. If not, I will continue. Okay. So what can an LLM do basically? I mean, just just a list of things here for you. So it can generate text or code. I'm sure you've seen this before. It can proofread text. It can translate. It can recognize speech. It can compare and summarize text. It can do sentiment analysis, which is something that we've been doing for a long time in computational social sciences. But now it has been sort of revamped and became much more powerful with the advent of LLMs and AI. General data science tasks. It can annotate text and images, and we're gonna try to speak a little bit about all of these. But the important thing here is that computational social sciences are not a new thing. They've been around way before LLMs came out. We've been doing sentiment analysis before. We've been doing topic modeling before. It's just that there are some things that are now happening at a much higher level than it used to be, just because we have these tools. And it's not trivial. The increase in performance is really not trivial. It's really impressive. The question we have to ask is, though, if the hype is warranted. So just before we speak about the hype stuff, we're gonna just bring you down once more and talk a little bit about the limitations. I'm sorry about this roller coaster, but I think it's really important. So yeah, the question is if the hype is warranted right now, right? And many people are thinking about AI will replace researchers. I think we are pretty safe for quite a while. There's still a lot of things that really LLMs cannot do, and thankfully research is still one of those things. I'm not sure if you're familiar with this hype pattern and trend. So in the majority of new technologies, when new technologies come, imagine there is this two-axis plot of expectations over time. And when the technology is triggered, expectations are very low, but soon, very quickly, depending on the technology, expectations peak and they get inflated. So we reach a peak here, and then after that we start going down to something of a disillusionment phase where we are getting really bad results from our applications of the technology. Then we're starting to get enlightened about what is actually possible and what we can do efficiently and consistently. And then we reach a plateau of productivity. So these are our expectations. This is what we can do with this technology. Right now, with AI, in particular in research, I think we are on the peak of our expectations. We're entering this phase of starting to slowly understand what really is not possible, and we're gonna speak a lot about that. But just one slide about limitations, which I think is again pretty crucial. These models, as I'm sure you've seen those that have used a chatbot before, they generally exhibit a tendency to be, very verbose. So they speak a lot about something. They write a lot about something where, in fact, the answer could have been given with half or even less of the amount of words they're using. Like super long responses. And also they're very confident, but sometimes incorrect in their responses, right? But they always sound very confident. That's because of the technology behind it and the nature, which is to generate an answer no matter what. And that brings us to the fact that these models make hallucinations. They hallucinate. A hallucination is seeing something when it's not there, right? That's the meaning of the word. So in LLM language, it means that because these models are generative, and the word generative means that they're starting from scratch and they need to produce something from scratch, from zero. Sometimes if the information has not been included in what they've seen, but still they have to provide an answer, then they can provide an answer that is wrong, that is not there. This can be problematic, especially for research tasks, right? Imagine we are asking a model to do a very specific research task and they start hallucinating and giving incorrect responses. That's not good, right? We don't want that. But in other cases, it could also be a feature. We want it to be creative. We want it to hallucinate and provide an answer that we haven't thought before, humans haven't produced before, and it's not in the data. That could be something like creative writing, right? Like thinking of new ideas about something, about a topic, or creating research questions about a topic, and we're going to see that. So it's not necessarily something bad. It's just a feature of these models that we need to be aware of. Also, you need to be very sure about what you're asking. Prompting is extremely important. So prompt is the thing you put in a box and you hit before you hit enter, and the moment you hit enter, that's what prompts pushes the model to start producing an answer, right? And that prompt is extremely important because models are very sensitive to biases in the training data. I'm going to speak about that in a moment. They're very sensitive to input phrasing. So they can generate different responses for very slight rephrases of the same question, the same prompt. So it's super crucial to make sure you are prompting it the right way. And we are going to definitely be speaking about prompting in the course in a couple of weeks because it's extremely important. But biases in the training data is also key, right? Because these models have been trained on vast amount of data, but this data has been produced by groups of people, by humans after all, right? And humans have biases that they bring into the text. And imagine you are training a model like this only on YouTube, on Twitter comments. You are sure that you're going to end up having a model that is going to be a little bit toxic, right? A little bit aggressive on the comments. Or imagine if you trained an LLM model only on US Congress parliamentary speeches from the 1900s. You are sure that there are going to be some probably male, white dominated stances in there, right? Just because that's how the Congress was at that time. So we need to be super aware of potential biases in the training data and how these get transferred in the response that we get from models like this. Finally, almost like second to last is that when we're working with models like this, sensitive data is really not safe, especially with any cloud-based like online solution. So I'm sure you're probably already aware, every university has its own rules about sensitive data, but you cannot process sensitive data on these cloud-based solutions because the moment you upload a PDF, let's say, with sensitive information and you hit enter, you can be sure that this document now, the information contained in this document is now property of OpenAI, right? They own that document. They can reuse it to retrain the model. So you also need to be aware of the fact that sensitive data cannot be used. So we might need some other solutions, and we're going to speak about those other solutions too. There's also a question about the environmental impact. These models are particularly resource hungry. So in order to train these models, you need super powerful computers that consume a lot of energy, but also when you run the model. So every time you type a prompt and you hit enter and it goes to the servers of OpenAI, these servers are comprised of super powerful computers that are very expensive to build, but also they're very expensive to run in terms of energy costs. So emissions is an issue, and the choices we make with the models we make can also be could be an issue. So right now there are funding bodies that require researchers to make thoughtful decisions about the way they use AI and LLMs in terms of their environmental impact, right? Then you need to add like a specific section to your applications about how you will mitigate these risks and what you'll do about it. So it's one more thing to think about. Then finally, it's also the question of cost, right? I mean, many of the tools we're going to see here are free. ChatGPT is free, but then it also has three more tiers of choices. So basically, I'm using Plus right now, which is 23 euros per month, which is not a trivial cost. This is quite a bit of a cost. So it started as a free thing, but then these companies, the way they work, the business model is that they introduce a technology, they make people dependent on this technology, and then they start charging. So we also need to be aware of that, right? I mean, the current Super Pro version costs 230 euros per month. This is an insane amount. And if someone depended on this, yeah, Hassan says that they will bring ads now. Yeah, it was just announced that they're going to start bringing ads. I mean, and this is just ChatGPT, right? I mean, this is going to happen everywhere. And uh, it's something we also need to be aware, right? As we increase our dependency on AI and LLM, we need to factor in that at whatever point they can either shut down or increase the cost. So we need to have mitigation plans, alternatives about how we do science, because we cannot be dependent as researchers on any given company. Right. With that, there are many ChatGPT alternatives, right? I love this slide because I've been doing talks like this for almost 2 years now. And initially, it was this super simple thing, ChatGPT in the middle, Google Bard on the left, and Microsoft's Bing AI at the time. Super crap, both of them. Only ChatGPT was good. But then Bard became Gemini. Bing AI became Copilot. Perplexity came out, very nice tool with nice grounded tools. Then Claude from Anthropic came out. DeepSeek from Asia, from China came out, very, very, very powerful tool, although it has gotten worse. And we also have European-based tools like Letsat from Mistral, which can be something interesting because their servers are in European ground. That means they have to follow EU regulations about data sensitivity and data protection. And it's something, can be interesting for researchers that need to abide to rules, right? Also, and I really want to stress this out here, local LLMs is a really good solution. So running any LLM from either super large one to smaller ones that can run on a consumer grade laptop like a MacBook or any other laptop is also a great solution that is out there right now. So with tools like Olama and OpenWebUI that you can just download, they are open source, they are free for everyone. People can run instances of LLMs, of models, of chatbots that they run on their machines. That means they are free. It means that they do not need an internet connection. So their data, their sensitive data is secure because it is all running in their machine. Nothing leaves the machine. And then four, you are capable of doing whatever application you want and not rely on any given company. So I really urge people to look at this. This is something which is not in the winter schools program yet as of now, but we're going to have a chat with Dr. Sumaya and discuss this if she would like this added, because I feel like it's a very, very useful way to overcome some of the obstacles we discussed before. Yeah, like communities like Hugging Face, which is this emoticon with the two hands on the outside, but you can just Google that now, is a community where you have it's a repository of LLMs about any task you might think of. And anyone with some basic Python programming skills, which you will get in this winter workshop from what I've seen, can really easily download the model and try to do any of the tasks that you can see here. So transforming text to image, text classification, image segmentation, text generation, so like whatever it is, and even more because this is also a smaller, an older slide. It's basically 3 lines of code. You download the model and then you incorporate it into some of the things you would have been doing anyway. It's very, very, very cool stuff. And again, free and open source. Right, and this brings me to vibe coding, right? So I'm not exactly familiar with how many of you guys are familiar with programming in general. If you've seen R code or Python code before, I know that some of you have never. So and that's okay. The idea is that vibe coding is this notion that with the tools that are out there right now in terms of programming and coding, you can basically ask an LLM to code for you. So you just ask it something. So I want to build an app, I want to build a website, and the model is producing the code for you. So you're not actually producing the code, you're just checking if the output does the thing you want to do. And that's called vibe coding. but beyond vibe coding, which is problematic a little bit, we should be aware of what the code is doing. We should be familiar with what the LLM is suggesting, because when it breaks down, we need to be there to fix it, although it can fix bugs as well. I just wanted to say that the positive thing here is that it has never been easier for someone that starts from scratch to learn and get into programming. This is by far the best time ever to start learning about this stuff. So there are tools out there like Visual Studio Code or Google Colab. I think we're going to be using Google Colab a lot in the workshop. These are just interfaces where you run your code, you hit enter, and the code is running. And because they are AI powered, they help you a lot with producing code. I just want to show you a really, really quick example about how that works. So anyone with a Google account, they can go to their account and open a colab.research.google.com notebook, and it looks something like this. I mean, you don't have to do it now, but just look at this. So this is a notebook where I can create text and I can write something like this is my cool notebook. I'm sure you're gonna get introduced to this later, but I just want to show you the cool thing about it. And now this is just text that goes up and down. But here I can also introduce code, and I can do 2 + 2. So this is Python code running. So the moment I click play, I'm gonna get an answer from the 2 + 2. Well, it's a bit slow because it's connecting now for the first time, but then I get an answer and it says 4. So I just programmed something, right? I just programmed 2 + 2, which means nothing. But imagine you want to do something else like importing a CSV file, and you really don't know what to do, how to do it. You can go on Google and say how to import a CSV file into Python, and Google is going to give you a response, etc. But you can also click on Google Colab or Visual Studio Code that I showed you before. You can click on generate or go here on the side where Gemini is running. Gemini is Google's AI chatbot, by the way, the model. And you can type here, help me import a CSV file. I mean, I can just type this, but because I know it's verbose and it's going to type a lot of things, I'm just going to say no comments, make it brief. That's because I know the kind of answers that it provides, and I can click send here. Now, my prompt went to Gemini, to Google's servers, and it's going to produce an answer. Okay, it's taking a little while right now. Normally, it's a bit faster. And look, it produced the code for me to import a CSV file. Yeah, I mean, this is phenomenal. And imagine you start typing code and something is not working. So if I try to run this, the file data.csv does not exist. So if I run it, it's going to give me an error, right? No such file or directory data.csv. That's understandable. But I have this super cool button here which says explain error. And I can click that. And now the model is going to try to tell me why this error came about. Again, it's taking a little bit longer today, but it happens. So the error blah, blah, blah means that the Python interpreter could not find a file name in the location it was looking. You likely need to provide the correct path. For example, you could try using one of the available CSV files. And it tries to help you and solve the error. If the error was something about your code, it would also suggest changes that you can also like accept. And the moment you hit accept, that change takes place. So in this case, it suggested that the data is somewhere else, right? So again, with the tools out there right now, there has never been a better time for you to get into coding. Like to do some of the research tasks we're gonna speak about, things are really, really easy to right now. So I'm gonna close Colab for now. You're gonna see a lot of Colab in the following weeks, so I'm not gonna keep on talking about this, okay? Right, these are IDEs, is where you code, where you do programming, but there are also coding agents. Coding agents are tools like Cursor, Google Anti-Gravity, and Claude Code. So these are places where you do vibe coding. So basically you type something to Cursor, like build me a website, and Cursor is going to provide all the Python code for you to do it. Same does Google Anti-Gravity, same does Google Cloud. Phenomenal tools for getting it to code. I would say that Cloud Code is a bit more advanced, and Google Anti-Gravity is the simplest of the three, and Cursor falls somewhere in the middle of the two. But you're welcome to try them out. I guess, with Google Colab, Google Anti-Gravity, like we're giving everything to Google. We continue relying on multiple things on Google, but it's your choice anyway. But there are alternatives out there as well. Okay, but I'm leaving this slide here for you. You can check them out later. Are there any questions right now? I'm gonna stop sharing for a moment. You can raise your hand if you have a question, and we can. Yeah, Dr. Sumeir, would you like to coordinate this? I'm also happy. It's up to you. I think Kerim has a question.
Let me coordinate.
Yes. Hello. Thank you so much for what you've showed us so far. Next to Google Colab, there was this other one. It's Visual Studio, I think. You
Yes,
didn't
Visual
speak
Studio
about that. How does it compare to Google Colab? Have you used it yourself personally?
Yeah, so I've been using Visual Studio Code for quite a while before AI came about. That's where, together with Jupyter Notebooks, are you guys familiar with Jupyter Notebooks at all? Just some nodding is good, no? Okay.
I've heard it. I've heard about it.
So it's basically where you do your Python coding. You can do it in Visual Studio Code, VS Code, or Jupyter Notebooks. It's just that the moment AI and LLMs came about, and these companies incorporated it into these interfaces for programming, Google Colab became, at least in my eyes, the more efficient thing. And just to share one more thing that I forgot about Google Colab, is that, so let's start with a new one that's simpler. Just want to show you that. So anybody with a Gmail account can run code right now here, as I did 2 + 2. So this is not running on my computer right now. It's running on Google servers, right? So this command is taking place on Google servers, not on my machine. So this 4 came about from Google servers. So, but this is a very, because it's the free account, because it's my Google Gmail account, I'm getting a very limited version of a computer, right? I'm getting a not very powerful computer. But here, if I click on runtime, I have the manage change runtime type, and here I can ask for a configuration of a computer with a GPU, graphics processing unit, which is what is doing AI. This is what you need if you want to do any kind of AI application. You would need some machine with a GPU. I can also have high RAM, because sometimes when my data set is extremely large, we need a lot of memory to process it, right? But the moment you click on high RAM or any of the GPUs, you need to have a pro account, which in my case I do. My university is paying for this pro account currently, but it also costs around $12 I think per month right now. So Google Colab also has this added functionality that VS Code doesn't. So VS Code runs locally on your machine. So the code that you're doing with VS Code is gonna run in your machine. So Google Colab is online. VS Code, Visual Studio Code is running locally. So. I mean, it depends on what you want to do. I'm currently doing all my Python coding in Google Colab. That's more than enough for the average person trying to learn about some of the Python applications. And I feel like it's a bit more intuitive. And with Gemini on the side, it's very, very helpful. Yeah.
Okay, so one last question. So since we're on the topic of IDEs, there's this one that was promoted to me by my friend. It's called IntelliJ. Maybe you've heard of it? IntelliJ IDE.
I do not know
You
it.
did not. Okay,
No.
then it's just my own research then. Thank you. Thank you so much.
Oh, you're welcome. Yeah, windsurf I've heard of, and it's on par with the other three that I showed, but I've also haven't used before. So again, just to reiterate, is just that the things that I put on the slides are things that I've used and I know work, and they are good. But I'm sure there are a ton out there that I haven't had a chance to see yet or evaluate. Windsurf is one of those, but I've heard good things about it. Yeah. Also, OpenAI has its own thing called Codex, right? So when you are in ChatGPT, here on the left you have Codex, and it works the same way as like it's a software engineering agent. So this is an LLM that you tell it to do something, and it starts producing as an agent on its own. It pulls the right libraries, it pulls the right packages and data, and it starts building the thing you want to build. That's the agent part in it. But Codex is another one which I haven't used, to be perfectly frank, but it's really cool. Any other question?
I have a question, Yani. So I
Yes.
was using Python on Jupyter Notebook, and I was introduced to Python before Gemini, before ChatGPT was released, and it was very, very hard to even, I don't know, create a small game at that time, 3 or 4 years ago. Now, when I realized that we have Google Colab with the help of Gemini, it was fascinating for me to see. And now I'm struggling like, how can we really introduce Python to students? If we have Gemini's help and you just open up Google Colab and then you write your, I mean, it's even able to answer your questions in the mistakes, errors. It helps a lot. So do you teach in your university like introduction to Python with the help of Gemini, or you just say let us learn the codes and the structure first before you introduce Google Colab and Gemini?
Look, we are going to speak about teaching in the last part. So how my university and general universities are tackling teaching, because teaching is another beast on its own, right? How we approach teaching with and without AI. I think we are in an age where you cannot overlook AI. It's just everywhere. So it's also in programming, but we have to teach programming, right? So it's in our case, and at least the way I see it, is that, I mean, we teach the basics on our own, but then we tell the students that this is on the side and it's here to help you. It's here to augment what we are telling you and what you can do, but it's also your responsibility to use it responsibly, make sure that what it's suggesting you is doing what you actually want. And so it's also about the technical aspect of learning a command in Python that does something, but also being able to evaluate when and if to use an LLM to fix and mend with your code, right? But I mean, we are at a stage right now where we don't need to learn code by heart. Like before, someone became an expert in Stata to do statistical analysis in social sciences, right? Stata is just one tool. I don't know if some of you are familiar with it, or SPSS, something like that. And it's like command-based things that it has. So you needed to learn all these commands to be able to do some basic regression, right? And if you didn't know, you had to Google for hours to find the answer and the solution to your problem. I mean, right now, we are at the stage where you don't need to learn programming by heart. You just have this tool on the side all the time that can tell you exactly what it is you're looking for and just speed the process up. But it is still crucial that you understand what each thing is doing, at least on a sufficient enough level. You don't have to be a computer engineering to do that. Yeah. I don't know if I'm answering Sumaya, but yeah.
Sure. Thank you.
Okay, if there's no other question and you are okay with that, I think we should do like a 10-minute break.
There are two questions on the chat, by the way.
Right. Sorry. Yeah, sorry, I didn't see that. Okay, we talked about Windsurf, Oma, I think, and Fatih is asking about if Olama. Yeah, okay, that's a good question. Is Olama working like Notebook LM but offline, and does it also hallucinate like ChatGPT? So Notebook LM, we're gonna talk about it a little bit later, but it's yet another tool from Google that is an LLM that is meant to do grounded stuff. So grounded in existing information. So I guess we might as well do it now. It's not a problem. I'm gonna speak about Notebook LM now as well. So if someone goes to notebooklm.google.com and they hit enter, they are greeted with this page. So these are my projects here, but I can also create a new notebook. So when I create a new notebook, I can name it whatever I want, and I can drop files here. And Google Notebook has the amazing thing, and it was really amazing when it started about a year ago, but now other tools can do this as well. You can upload really tons of text resources to begin with. So it allows you for up to 50 documents, PDF documents. But inside a PDF, there is no limit to the size of them. So you can also put 50 papers into one PDF and upload it as one. So you have 50 papers in there. And then when you can also upload websites, links to websites, YouTube videos, Google Drive files, or just copy plain text in here. And the moment you do that, then the notebook. So for example, let's say I want to upload some files. Just give me a moment. Haven't prepared for this. Yes. So imagine I have these 4 papers here. So one is about parliamentary questions. We're going to see this. So this is a paper of mine. I wrote this. And it's about parliamentary current questions, constituency focus under times of crisis. It's about parliamentary questions and how they are used. And I have these other 4 papers, right? They are all academic papers. So I can upload these here. And Gemini initially is just gonna create a summary of these 4 papers. This is not new. We know this. It happens elsewhere as well. This is not something crazy. Let's give it a bit of time. Looks like some things are working slower today. Yeah, it's taking some time, but so in the meantime, I'm just going to speak about Olama because the question had 2 parts. So Notebook LM is about entering documents and speaking up interacting with this document. It's about digesting and putting information together and digesting tons of information. And then once the information is uploaded, you can ask questions and interact with these documents, right? That's what Notebook LM is doing best. It also has some amazing tools that I feel like they're a bit gimmicky. They're a bit, more like hype and less actual value, like creating a video overview of what you're saying, an audio like a podcast or an infographic. I mean, I don't really like these. I haven't used them, but they might be useful for some people. I don't know. The cool thing in my eyes is that you can now ask questions. When these are uploaded, you can ask questions to the model based on these documents only. So remember, an LLM has training data, and it's data that was there when people created Gemini 2.5 or whatever it is right now. So anything that happened after that date is not in the training data of the model. So if you want an answer that is grounded on some factual elements, Notebook LM is the place to do it, because you can then select documents or select all of them or select a couple of them and ask a question only based on that. So imagine you have like legal documents about specific laws, you can ask Gemini to give you a legal answer based on this and this and this document only. So it grounds its response on its training data and the collection of documents that you provided. Does that make sense? Right. So that's what Notebook LM is doing, and that's totally different from Olama. Of course, this model can also hallucinate. Notebook LM can also hallucinate, but Notebook LM is what is promising is that it can ground its answer to the documents that you provided, and if it cannot find the answer here, it's gonna tell you I couldn't find the answer, which is not common with other LLMs, right? Olama. Olama, on the other hand, is a platform, is a tool that can help you run LLMs. It's not an LLM. It's just a platform which allows you to run a model locally. So if I hit Olama, which I have in my computer now, this is an interface like ChatGPT, but the model I have now is Gemma 3, 4 billion parameters. This came pre-installed, but I can install other models here. It's beyond the scope of this talk right now, but we should do it at some point. But I'm going to ask something here. So who won the 2026 Africa Cup of Nations trophy? So this happened just yesterday or like 2 days ago, whenever it happened. And I suppose it should know, also spelled trophy. Anyway, this is just a fun question, but what I wanted you to know is that right now I sent this question and I hit enter. This did not go online. This did not go to some server online. It's running now on my machine. My computer I have on my desk right now is doing this computation and it's providing me an answer. And that's why it's taking long, because this is a big model and I could have selected a smaller one. But now it's checking and it's producing the answer, as we said before, token by token, on my machine. I could have, one moment, Kerim, one moment. I could have turned off Wi-Fi right now and I would still get an answer here. And Olama is just a platform. It's a tool that allows you to run models locally. It's phenomenal. It's amazing, and everybody should try it because it has this easy interface, but you have other tools. And I mean, the answer still hasn't been created. I mean, this can be worrisome because maybe the question is difficult. But anyway, here on Llama's page, I have docs, not docs, models. So I have all the models that are available, and these are open source models. They are not a proprietary closed model from a company like OpenAI, which we don't know how it was trained. We don't know, we cannot use it. So these are tools that I can download on my machine and use for free without asking anyone, and they're running on my machine. It's phenomenal, and I think we should dedicate some time to this, but I think it's a bit beyond the scope. So Notebook LM is not running still. No, okay, we got an answer. As of today, November 2, 2023, that's the training cutoff date for Gemma 3. That's when it stopped getting data. The 2026 Africa Cup of Nations trophy hasn't been awarded yet. Again, this is an answer that has been produced entirely in my machine. No server, no one else's computer, no one else's server, and for free. Imagine I'm in an airplane, I'm on a train, I'm somewhere without Wi-Fi. I can have an LLM answering questions of mine without requiring anyone else's help. This is super cool in my eyes. I hope it's cool for you too. But someone had a question. I think Kerim, was you?
We feel like we can give a break. It's more than 1 hour for you, Yani.
Yeah, but it's okay. I like this. We should be doing this as interactive as possible. Okay, if no one else then has a question, then how about we take 10 minutes? So at past, I'm gonna turn on my camera again and we can
30.
continue. Okay.
Okay, sure.
Thank you.
Thank you.
Okay, thank you.
Okay, see you all after 10 minutes.
Yes. Okay, so we're back. I think I should start. I should continue, should I say? So, yeah, we are now here. I'm gonna share again the screen. Okay. So, I think it's better like this. All right. So basically now the question what we're gonna answer beyond the rest of the things that we've seen, the practical stuff is actually how can AI and LLMs help me in my research? Like how can it help me do computational social science better? Hopefully better. So first of all, I'd like to start with the fact that LLMs are already used for generating research ideas and generating novel research ideas. So there's this study, not that long ago, but quite some time already, and I think there's been more studies after this, that in which they recruited over 100 NLP researchers to write novel ideas and also blind review LLM and human ideas. So they had LLMs write ideas and scientists write ideas, and they had 100 researchers evaluate both. And what they found is that the LLM generated ideas are judged as more novel and statistically significant finding than human expert ideas, while being judged slightly weaker on feasibility. So what LLMs do is they have novel ideas, but maybe they are not as feasible. But still, they are already being used for generating ideas. They're also being used a lot in social sciences, behavioral and social sciences. Although closed models are more in use right now in publications, right? There are some AI aggregators as well out there. An AI aggregator is a place where you get accumulated information about tools, in this case AI tools, about anything. So you go to, there's an AI for that, for example, and you type a task that you want to do, like let's say audio transcription or something like that. You hit enter and you would get the results about these about the tools available with reviews, etc. So again, I like this because I like this slide because when I first started doing these, there were 5,000 AI tools for 1,460 tasks. But if you now click on there's an AI for that, you're gonna see almost 45,000 AI tools for 11,000 tasks. So you see, like that's beyond exponential in terms of growth. But let's speak a little bit about literature review, right? So you can do literature review right now with AI tools, and this is something that can be extremely useful. There's research right now that is developing prompt templates to do proper systematic reviews and model-driven screening of papers. So they are developing some prompt templates to screen full text and abstract papers and can be adapted to different reviews. So there's a lot of work being done right now on systematizing how we can use LLMs to do systematic literature reviews, right? So this is not something that I'm pulling out of my head. Researchers are already doing this, and you could be doing science of science research about how this is being done, or you could make a contribution telling people how to do it and how to use LLMs for different research tasks. Of course, there's a bunch of tools. Don't really pay attention too much to this slide because this is slightly old and not all of this works here. I think I'm gonna remove it before I share it with you. But there are a bunch of standalone tools to interact with academic papers. So in all of these tools, you upload a PDF of a paper. I'm not sure if you guys have done this before. So on ChatGPT, for example, I can take, let's say, that paper of mine that we saw about parliamentary questions, and I can be like, summarize this paper for me, and I hit enter. And now this paper, as I told you, goes to the servers of OpenAI together with this prompt. It's gonna read the answer, and it's gonna read the paper and provide an answer. So we are in the thinking one, and it's a bit slow. So here's a clear structured summary of the paper, blah, 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 by Yani Kartalis. The paper investigates this one. Main question, do MPs become more or less constitutional, blah, blah. In doing poorly or well, it says the case and data, the theoretical expectations, the methods in this case. So again, a very verbose. Maybe I didn't want all of this. Maybe I just wanted this, right? Depends on how I prompt the model, I will get a better or worse response. So you can do this right now in ChatGPT or in other models. But what these tools are promising is that they are fine-tuned for academic writing. So they can do a better job in summarizing and interacting with these models, interacting with these documents that are academic. But by far the tool I really want to talk to you about is Elicit. Elicit.com is not a free tool. It has a free tier, but the really cool stuff are behind its pro version. And if you now click on Elicit.com, you get a 14 days free trial of the pro account, and you can just decide. I have 3 days left, but you can just decide. If you go to pricing, you will see that the pro is actually $50 per month, but the plus one is more than fine. It's really, really, really good. But also there's a free version with some limitations, and I'm gonna show you what they are. So in here you can also do paper chat. So you upload the paper and you chat with that paper. So Elicit, by the way, is a tool that has been created by a bunch of organizations, including Stanford and some others. And they are meant to be doing to be dealing with academic paper. They have their own database of academic papers from which it draws data from, and it searches for papers. So it's Google Scholar on steroids, but on AI steroids. But it's potentially not as exhaustive as Google Scholar. So Google Scholar has a higher chance of having a paper indexed, a very recent paper, versus these databases. And some papers that are behind paywalls sometimes might not be in these databases or not. Another caveat that I wanna speak about before we start is that they are also these are tools that have been primarily built by hard sciences scientists. So you will see that there's a lot about clinical trial data. Generally, the positive sciences are a bit more represented here, and social sciences, it's much more likely that a social science paper is not going to be in the database versus the hard sciences one. Having said that, it's still phenomenal. So as I said, you can do paper chat. You upload a paper here, or you select one of the existing papers and you ask questions about it, similarly to what I showed before. But you have this tool here, which is called Research Report. So you can ask a research question here right away. And the model is gonna, if you go to find papers, the model is gonna search for papers that are similar to the research question you're asking. So if I say, how do parliamentarians use parliamentary questions to represent? You can try this with something that you are familiar with, so that you can evaluate the response as well. So it also evaluates your question. It says good research question, consider adding these elements for better results. So methodological approach, and it's making a suggestion on the top, as you can see. Or comparative perspective, junior versus senior legislators, or specific, like these are pretty cool suggestions, by the way. But let's keep it vague, and I hit run. So now the model is going all over its database and it's trying to match abstracts and titles if it doesn't have the full text, or the full text if it has the full text, with your topic. And it's providing you a list of papers that are about the topic. So I know the topic, so I can tell you if these are good resources or not. So this is a great one. Not so much. This is a fantastic one from Shane Martin. Great one again. I would have liked to see my paper here too, but okay, here it is. My paper is there as well. Because I'm actually answering the exact same question, right? So it also provides a short summary of what that paper is doing, and you can try to get full text if they have them. Anyway, it's just a quick and easy way to enter into a topic, get familiar potentially with a topic, and start your literature review, not from a completely blind spot of going paper by paper, right, as we would normally do. This is by far not an exhaustive list of papers, right? It's not meant to be considered as the literature review on a topic. It's just a way for you to familiarize yourself with the topic. And then you can also add the other elements, but let's go to, no, let's do it here. So you have the option of adding a column and extract specific information. But no, I want to do it the other way. Sorry. If you click on the research report, you can ask the same question. So how do parliamentarians use parliamentary questions to represent their constituents? And I hit enter again. It's evaluating blah, blah, blah. And I hit enter again. Now I have the option to go with fast, balanced, or comprehensive. And I'll go with fast just for the sake of getting an answer quickly. And that will generate a response. It will gather resources, screen the sources, filtering the studies based on the inclusion criteria it thinks it got from the question I have. It will extract data from the papers and it will create a report by it. And this will take some time, and when it's done, it's going to send me an email to my Gmail account. And I'm going to show you that later. While it's doing that, I'm going to show you a previous report that I have created, which is this one. And you will see that it's trying to answer the question, right? European parliamentarians use questions as flexible tools to demonstrate responsiveness to local concerns, signal effort to constituents, blah, blah, blah. But this is not a general answer from a generative model that has just been trained, because I can go and ask the same question to ChatGPT. By the way, the in Europe thing was added later. I didn't add it, but anyway, we got it. So great question, blah, 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 signal attention, channel grievances. It's going to do the same thing, but this is not grounded on research. It's not grounded on papers. This is the way we discussed before of generative model creating word by word based on what it has seen before. It has seen a couple of papers, obviously, and it has the capacity to answer. And maybe this is a great answering way of answering this question too, right? I don't want to rule this out. Just that I know that this answer here from Illicit, it's based on resources. And for everything that it says here, you're going to see a little star here that tells you exactly where it found that answer in the papers that it has listed. So we have methods, how researchers have studied the topic, and it shows you a couple of papers, including this one. I'm happy to see that there. And also it does thematic analysis of the topic, very, very substantial stuff, synthesis of the topic, always with references to the things that it's saying. And I've seen this report a couple of times because I've demonstrated this before, and I know it's a high quality one, but I also wanted to show you this. I wanted to show you that Illicit has the extract data function where you can select a couple of papers. So it's selecting this, I've selected this paper, one is mine, For some reason, it has no title. It has title not found, but anyway. And here I can add columns now of data that I want to extract from papers. So imagine I've done my literature review and I reached a total of 50, 100 papers that I think are relevant to the topic I'm working on. But I don't want to read all 100 of them. I just want to see what's relevant for my specific task. I can add columns here. So obviously I can add a summary. That's not a hard one. We've seen this already. Now it's creating a summary for each of those. Again, things are a bit slower today, but normally it's a bit faster. But I can add other things like funding source, like dataset, like hypothesis tested, like study design. Maybe I just want to focus on cases that are using a specific research design. Maybe I'm only interested in specific hypotheses being tested. Maybe I care about cases that are countries in Europe. Maybe I want to look only at countries in Africa or something like that. So you can extract this information consistently in this manner, and the LLM is going to go to the paper and try to find the answer to the thing you're asking. Now, again, sorry, it's taking a little longer, but so here it says that the dataset for this paper consists of written parliamentary questions asked by British MPs, one observation and 8,000 observations. So you don't have to go to the paper and read the entire thing to find that piece of information. You can have it done systematically for multiple papers, right? As always, we're working with LLMs. We need to verify that this was a correct answer, but this is just a way to speed the literature review process. I hope it makes sense. Okay, and I'm gonna leave Elicit for now, and we can go back to it. I'm not sure if the initial report finished. The other report I asked. So it did finish, and if I check my email, I think I should have an email by then. But anyway, let's not. Okay, it's generating reports, so it hasn't finished yet. Yeah. So that was Elicit, one of the potential tools to do literature review. But in the meantime, I also want to make some like honorable mentions. So Research Rabbit has been there for a long time. I think someone turned on their mic. Sumaya, do you have a question?
Yeah, there's a question on the chat.
Oh yeah, sorry, I missed that.
It's okay.
Yes, for sure. One way to use Elicit is to try to identify gaps. So the way you would do it is, I mean, obviously your feedback would go in there. You'd have to see the paper, see the report that Elicit created, and try to discuss with the literature on your own. But when you have a report like this, and you have the chat with papers, you can ask anything about the results, about the papers, or what has not been asked. So you can be like what is one thing that is left unanswered from these papers, or something to that effect. So, and I mean, this is only again one quick suggestion of how to do it, but there are other ways for you to do it. And we can discuss this later on if you want, but let's not dwell too much time too much on this. But I hope I'm answering. And Emir is asking if I have experience with dimensions.ai. No, I do not. Is it something similar? Would you like to tell us something about it? Okay, no worries. So you're welcome, Idlib. So I just want to say that Research Rabbit has been there for quite a while. It's not something completely new. It's like the original literature review tool that connects paper, connects citations of papers as well. It's a really nice tool, and I want to mention it as well. You can look at it. Consensus is a really nice as well new AI tool that is doing literature review, but it calculates measures of agreement between papers. So, which is something that can be very, very valuable on a given topic. And then SciSpace is an alternative to elicit. It's also academically backed by many organizations, and it's really cool. I suggest you take a look at that as well. And it has a sort of more beefed up free version, although the really cool stuff is behind the paywall as well. And I'm sorry, I'm suggesting two tools that are yeah. So Ayman is saying that deep research feature in ChatGPT produces result that is grounded on real research. Yeah, it's just that ChatGPT does not make any claims about the database of papers that it contains, whereas Elicit or SciSpace, they are making claims about what the database is. They are upfront about what the database is, where they get their data, what is included, etc. How close it is to that research question. It calculates metrics of closeness. ChatGPT is just providing an answer for you, be it in the deep research or not. But yeah, you're right. That option is there. So I'm now not entirely sure where you got it anymore, but yeah, if you have an idea of where you activate it, you're welcome to let us know. I'm afraid I'm not sure where it is right now. Anyway, I will continue if that's okay. And then there's the explain paper tool that can summarize papers at different knowledge levels. You can be like feed in a PDF of a paper and say, explain this to a 5-year-old. Explain this to a PhD level student, explain this to a postdoc level or whatever. And it's really cool as well. Finally, with tools, there are these citation checkers. You just feed in a list of citations that you have for your work or that has been provided to you by an LLM, and you can check if these are corresponding to some existing database. So Ayman, and I'm sorry I'm returning to this, but this is interesting, and thank you for that, Ayman. He says that he did a comparison between a literature review done by SciSpace and ChatGPT, and found that it sounded to me that the former used ChatGPT, in the background to produce almost the same results. Sorry, I'm not sure I understand. ChatGPT, of course, it used ChatGPT in the background, but maybe I'm misunderstanding something here. If you care to explain, I'm just gonna give you one more minute. Yeah, so SciSpace is using ChatGPT, I guess is what you're saying, right? Maybe I'm wrong. Yeah, so maybe you agree as well. Yeah. So yeah, I don't think it's ChatGPT. It is an LLM in the background. It could be potentially at some point, maybe SciSpace is also using, but I would argue they have their own. Yeah, so here it says write a research task or choose one below, and SciSpace agent, so the tool they built, will use the best AI models, which I guess we don't know which ones they are, but yeah, and I'm afraid I don't have an answer. I should have an answer though. So yeah, so like what AI model SciSpace uses particularly, I'm not sure, and I cannot say for certain that they're not using ChatGPT, the models behind ChatGPT, so GPT-5 or something like that. It is possible that they're doing that, but still they are grounding their answer to their own data sources, their own collection of papers, which is not the same as what's behind OpenAI's servers. I hope that makes sense. Okay. So let's talk a little bit about collecting and processing data. And once again, I would like you to go to Slido to answer one quick question, if that's okay with you. So just scan this QR code and we are gonna go to Slido. Here you are again. Now we're gonna have a different question, so just give me a moment. Yeah, if you are already there, just refresh it and you can start answering this question. So what type of research methods do you primarily use in your work? Or planning on using? Maybe you're not using yet, but you're planning on. I'm afraid we haven't had I think Dr. Sumaya told us about the level, the academic level of participants. It's somewhere in the documents you shared, so I'm sorry. Okay, so once again, about 40 of you voted. Thank you so much for that. And we can see that, almost half of you guys are mostly using qualitative methods. But there is about one every five of you that is doing also quantitative methods, and that's great. And there's also one every one in every three of you guys, which is very cool. You're using combinations of quantitative and qualitative. I hope also in mixed methods designs, which is something that is very powerful right now. So we can do really cool stuff by combining the depth of a qualitative analysis with the breadth of quantitative stuff, more computational stuff. I think the sweet spot right now for doing really high quality, high level research is combining the two somehow. And this is one of the things we're trying to do at SODA. It's not really easy all the time. People coming from different backgrounds have their own set of preferences, but also habits, right? So it's not completely easy to do that. But trying to combine can be very, very helpful. Anyway, with that in mind, we're going to talk about both qualitative and quantitative methods in the next half hour, I guess, something like that. Yeah. So let's start by talking about qualitative data. So I guess you are familiar already with tools like NVivo for qualitative data analysis. So tools like NVivo, which is very, very helpful, where you can go to data, look at text data and annotate manually, and then quantify the manual annotations that you did or other stuff that you can do. It has been here for a while, since 1997, but since the version 15 from 2024, it now has AI components in it. So these components can summarize documents, can offer many kinds of data visualizations that are very helpful in my eyes. But it is still very expensive and slightly unintuitive. I mean, it can do many things, but figuring out how to do the thing you want to do, which is very specific, it's often very complicated. And as I said, it's crazy expensive. Also, there is no guarantee that your data is safe, right? If you're working with sensitive data, let's say interviews that are sensitive data, there's no guarantee that they're not going to use the data to train an AI or use it in other ways. So yeah, in the event of suspected abuse, and improve the AI services. So outputs may infringe the intellectual property rights. So you by using a model like a tool like NVivo, you're not sure that the sensitive data is protected. With that in mind, something that actually came out of SODAS is this tool called EthNote, which is it started as a field note tool that would systematize how field notes are being taken. So it started by a project that had a need to field multiple researchers in an anthropological project that wanted to observe people and take notes about how they did certain things. It was a political science project, anthropology and political science. And they went into a location that everybody needed to take their own notes. but they had to systematize how people took notes because everybody has their own system and it's not always easy. So they created this tool out of the need for that project, but that has turned into a spin-off. So the University of Copenhagen has helped them create a company that sells this now as a tool, and it's called EthNote. And it has an online based, but also an app version as well. And the reason I'm like pushing for this is like I'm not affiliated with Emily. I know her, but I'm not affiliated with her. It's just that it's an AI-based tool that allows you to do systematic qualitative data analysis like in vivo, but in a much more concentrated way, research-focused way that is not as convoluted and definitely not as expensive as in vivo. You can go to their website and check it out if you want. It is also GDPR compliant. It's hosted in Denmark. And I mean, if you care about compliance and sensitive data protection, they do that as well. So it helps with collection, collaboration between users, curation, and also they have AI tools in there incorporated that allows you for really cool analysis of the data that is automated and based on pipelines that have been tested by them. Don't know if you have any question on this. So one really cool thing I wanted to talk to you about is interviews and what we can do with AI and chatbots in terms of interviews, right? So what is the good thing about interviews, right? It's quality. It's the capacity to go in depth and get answers that some like very basic, rudimentary, or even elaborate survey cannot get to, right? So some respondents want to answer in a way that has not been predicted by researchers, and it's not in the question. So you have the capacity with interviews to go into a level that you cannot do with other tools. But at the same time, interviews have a lot of cost involved with them. Cost in terms of time, cost in terms of paying the interviewer to go and do the interview. And normally, studies that rely on interviews are not, lack the numbers for making inference, right? Inference. At the same time, surveys, on the other hand, which are a quantitative tool, they cannot go too deep, so they lack that depth of interviews. But they can also, because of the low cost, they can reach many more respondents, right? So a lot of researchers right now are working on bridging these two methods, and they are thinking about doing it with chatbots. So there are two projects right now running in the University of Copenhagen, one by Felix Chopra, who wrote this paper in 2023, and one by a colleague of mine, Hjelma Bang Carlsen at SODAS, and that they are developing how to use artificial intelligence to conduct interviews. So imagine you have a regular survey that has the regular demographic questions or general questions that we normally ask. And then at some point, the question turns into a chatbot interface where a model that has been fine-tuned to do a very specific kind of interview, to do a very specific, to ask very specific questions with predetermined goals by the researcher, is interacting with the respondent. So it would look something like this. So how old were you when you first started thinking about the green transition? The person asks, I think I was about 20 years old before I started playing and paying attention. And then the model asks the reviewer, the AI interviewer, do you recall any specific event or piece of information that sparked your interest? I took a course in a Danish high school about sustainable entrepreneurship. Okay, what was the impact of this course? Now the respondent is answering. So imagine in the context of a survey, where we are only bounded by the time of the respondent, but we're not bounded by some extra cost of the interviewer being there, doing the interview, taking notes, etc. It's just a model taking down the answers and answering. We can potentially bridge the two worlds, right? I hope you see this. I mean, this is very cool and can have a lot of potential. But obviously a lot of caveats, because what happens when the user understands that they are talking to a model, right? Do they change their answers? Does desirability bias increase or decrease? Do they lose faith towards the research validity? Or these are some of the things we need to investigate. But the tool is being developed right now to do this, and I find it pretty cool and promising. But we have to obviously answer questions like this. But still pretty cool stuff. Now, a little bit about quantitative data as well. Obviously, sentiment analysis is something that people did with LLMs right away, and we used to do this for a long time with dictionary methods. But models like GPT-4 show a lot more correlation between human ratings and model ratings, assuming that sentiment analysis is something we can easily do as humans, because it's also like a complicated task. It's not very easy to do anyway, in principle. Yeah, there is a lot of work being done about prompting and how to score prompts to do annotation of data with LLMs, and I'm gonna speak about annotation, but then also go back to the in vivo convoluted expensive premise scenario. So this is something I did 2 years ago with the help of AI. So I worked for a project that wanted to annotate 5,000 articles from Spanish and Portuguese newspapers. So in order to do proper annotation with intercoder reliability in both languages, we needed about 15 coders working on the data. And that meant that we needed to pay, so sorry, this is in Danish krona, but it's about 13,000 euros to get 15 licenses to do one project. I mean, a small project does not have that kind of money, obviously, right? So we needed to find a solution. So what I proposed is, and at the time I had no experience with working with Shiny apps, something that you can do in R, and you can develop some application interface with R. And the solution was to work with ChatGPT. So I asked ChatGPT. At the time, there were no coding agents. There were no Google Colab with Gemini on the side, just ChatGPT that could help you with code. And I asked ChatGPT, how can I build a Shiny app with this and this and this format that has an article window on the side, then has some buttons for going next for annotation, and then some buttons for annotating for the user. So what I did is I created this app that allowed the PI of the project to hand this to their annotators, and each annotator would get an article, some annotation buttons, a save, and a next button. So this is a streamlined version of their task that is only focused on the task at hand. No extra buttons, no additional noise here for the users, and it made a huge difference. Okay, obviously in cost, because it took me I don't know how many days, and I was paid for my days of work, which was only a small fraction of what they would have paid for doing it with NVivo. And I would argue that if I were to start from scratch now with the tools that are now there, I would do this in like a day or so. So just something for you to think about. Another thing I used AI a lot for, and I'm planning on teaching this at the winter school as well, is doing quantitative, so large-scale data annotation using LLMs. So this case, as I showed you before, this is manual annotator. So humans reading the data, providing some response, and then saving that response. So that's manual annotation. The idea with AI-based annotation is that we ask an LLM to do that same annotation. So we take that same text, we put it to ChatGPT or some model like that, and we ask it for the exact annotations that we would have asked. And then we hit enter, and we expect to get the annotations back. I was in a project that had a data set with 100,000 parliamentary questions, like we saw before. That's the paper I showed you before. It was based on this. And we had a 21 class classification problem. So I don't know if you're familiar with the Comparative Agendas project, but it's a project that systematizes policy areas, and it has these 21 policy areas from macroeconomics to foreign trade, to transport, etc. What I wanted to do is I wanted to classify these 100,000 questions into these categories. So I wanted to know if a question was about health, was about agriculture, was about environment, etc. So I used OpenAI's models and the application programming interface. So you are going to speak in the workshop about application programming interface and how we access those. Very, very useful knowledge. Basically, it's a way to access a service programmatically with Python or R. And I used GPT 3.5 Turbo at the time, and it took me $20 and a code running for about 6 hours. My computer was running for 6 hours, and I paid $20 to annotate these 100,000 questions. If I were to have manual annotators doing this, it would cost me exponentially much, obviously, right? Just for the time they would take them to annotate the data. But this is only $20. It's an insane efficiency gain. But are we sure that the annotation was good? Can we be for certain that the LLM did a good job? So obviously we need to create accuracy metrics. So we take a small sample of those 100,000 questions that we manually annotate. So not the entire set, just a small fraction of it, like 100, 200 questions. And we see if our annotation matches the model's annotations. And if it has a high level of accuracy, we can be confident that that's the same for the entire dataset. In my case, we had 75% agreement between human and the model annotation for single class. So when we were asking the model to return only one of these 21, and when we were asking the human to return only one of those. But if we asked it to return multiple, and we were comparing if at least one of them was shared, we got 95% accuracy, right? And already 75 is really high. But for today's standards with GPT-4 out, GPT-5 out, 75% is a bit low. So we need something higher. Although a 21 class classification problem is really not a trivial task, and we should not brush over it that quickly. It's an extremely difficult task that with previous tools like machine learning algorithms that we had before the LLMs, it was extremely hard to do. You could not do 21 class classification with 75% accuracy. Is this clear? Okay, cool. I'm just reading another question by Yunus, but I think I missed it. It was a bit earlier, right? I would like to try to answer it now, though, if that's okay, because I'm almost done with this part. So especially for anthropological and sociological researchers, during interviews, emotions, mimics, and silence, etc., are also important as data. How can AI catch this? I mean, that's a good question, but obviously it can't, right? I mean, we're talking about an interface tool right now that is just interacting with text. I mean, right now, chatbots are becoming capable of producing audio. So they sound like a person speaking to you. They digest your audio, turn it into text, and they understand that and they speak back. But obviously, we're not there yet. I mean, as I said, humans cannot really be replaced, at least as of yet. We're not there yet. So this idea that's why I really wanted you to pay attention to the fact that our model, a generative AI model, is just there to generate tokens. It does nothing more than beyond that. It looks like magic, but under the hood, it's a very simplistic thing that it does. It really is not. It's not even close to general intelligence as we're talking about. It's not even close to handling other tasks yet. I mean, we have agents, but we're not there yet. And I hope that's clear. But that's a great question. I feel like I feel like we are a long way to be able to capture stuff like that with AI. However, there are tools right now that capture facial expressions during interviews, right? So you could try to capture emotions by looking at analyzing images and video of people talking. This is happening, I know. You can also capture silence by having audio files and looking at sessions of silence. There are other ways to do it. It's just that it's not LLMs, these ideas that we are speaking about now, that does that. I hope that answers Yunus. Then Admir is asking, do we have replicability when using these AI tools? Did you test this? That's a phenomenal question. That's an excellent question. It's right to the point. So science is meant to be replicable. So when I'm doing a pipeline, I'm doing an annotation, I'm using some data, the ideal way is that someone that comes 10 years later can take the exact same data, can use the exact same model, and reach the exact same conclusion, make the exact same findings. The problem with using OpenAI's API and a model like GPT 3.5 Turbo is that if I now go to OpenAI, if I go to OpenAI's API, and I log in, I think anyway, what I wanted to show you, I mean, it's not a problem, is that GPT 3.5 already is discontinued. It's not available now. So if you wanted to replicate my paper, you wouldn't be able to. And this is me using a proprietary model, something that belongs to a company. So if they want to discontinue it, they can discontinue it. So this is also crucial, right? If I were to submit this paper today with a closed source model, with this pipeline, this annotation that I did, with the caveats that it has, and we can discuss this in 3 weeks' time, it would not be published today. It would not pass the review process because someone is going to say this is not going to be replicable any longer. So this is a great question, and we need to be aware of this. But we're going to discuss about ways to do science with LLMs that is replicable. I hope I'm answering. So Fatma is asking, how would you compare Elicit with Gemini plus NotebookLM integration? Since Gemini can also access and analyze. So before I go to that question, because I feel it's a bit more general, I wanna complete this quantitative data part, if that's okay, Fatma. But I'll get back to this question, okay? So as I said, remember, we can do fine-tuning with models. So there is research now that is building case-specific LLMs, and they're making them open to the public to be used. So there's a model, for example, called political LLM. So it's has been trained to work with political data, like parliamentary speeches or press releases from parliamentary parties, manifestos of parties, etc. So we need to be aware of the existence of these models, and they are all on Hugging Face. So anyone creating a model, they are going to upload it on Hugging Face that we talked before, right? So you are able to download this model and use it on your own. Speaking back to the replicability issue that Admir raised as well. Obviously, we have images and computer vision that we can use. So beyond text, we can analyze images with LLMs. We can classify images, can estimate depth, detect objects, segment images, split them in parts, can classify videos the same way we do with text. And many people are using this in social sciences, so in very creative ways, like checking if politicians standing in photo shots after some major meeting event. So, for example, the Prime Minister, so Trump meets Zelensky, and they take a photo. After the meeting, they are annotating with the help of LLM the facial expressions of the two politicians. So like pretty cool stuff. Or like the types of clothes they're wearing, if they're wearing ties or not, how many women are in meetings. So they're doing really cool stuff with that. So another researcher in the political science department at University of Copenhagen, they are working with tone and style of male versus female parliamentary speakers, and they are transcribing they're not transcribing, sorry, they are using the audio to see the level of their voices, stress and other factors in the level of voices, how they utter their speeches. And obviously, they transcribe the speeches and they check for vocabulary use, more eloquent speech, or more basic speech, more popular speech, etc. Very cool stuff. So that leads me to transcription, and I'm gonna stop here because I don't think we have too much time anyway. So transcription is another thing you can do with LLMs very well. So Whisper is a model that is open source. It's from OpenAI, but it's open source. It's for everyone to use and download. And tools like Buzz Captions can do locally on your machine. So you can use sensitive data, sensitive recordings, and you can run it on your computer. Multilingual, so Turkish, for example, Turkish and Arabic are both very well supported, and they have really good results. So imagine you have an interview that you want to transcribe, you can put it in Buzz, and you get a transcription in a couple of minutes that is phenomenally accurate. And this saves a lot of time, because transcription used to be something that took a lot of time by people to do manually. Yeah, at this point I'm gonna stop and make another 10-minute break. But before, unless we have some other question, I'm gonna take another break. But I'm gonna answer Fatma's question in the meantime, which says, how would you compare Elicit and with Gemini plus Notebook-LM integration? Since Gemini can also access and analyze our own documents, can we consider it as an alternative or a complementary tool to Elicit for research workflows? I would argue that all of these are complementary. None of these is like a one tool that solves every problem. So depending on what you're doing, I can see various scenarios that one is better than the other, and various scenarios that you might want to use both. I feel like Elicit is more for getting a hand of a literature, finding papers, and getting into a literature, starting from a good starting point. And then Notebook-LM and Gemini can help you more for digesting all the literature that you found, putting it together. I don't know. I hope I'm answering, but that's my way of using these two. So let's take 10 more minutes. So I just need a break to for my thought. I hope that's okay. We have a couple more things to say, but we're gonna be soon done. Okay, let's take 10 minutes break, and we're back at 35 past. Okay, thank you so much.
Sure.
All right. Let's continue. I have a very small section here about the fact that, I mean, this is a little bit beyond AI and LLMs, but obviously it incorporates AI and LLMs. It's just that computational social science allows us to do a little theory building as well, but sometimes we forget. As social scientists get exposed to these tools, um, they figure out ways to do certain things about theory building as well. And some of it is people can use digital data, computational methods, and obviously AI and LLMs to test theories, right? Because when we get access to new data or new tools, some aspects of social theories now become testable that were not testable before because we didn't have the tools to do. I mean, they allow us to measure some aspects of social phenomena that we couldn't before. And we can also now look for new data sources or new methods to test old theories that have been on the drawer for a while and we considered as done. We can now retest them with this new data that we have access to. And here comes like a creative act of what we need to be doing, which is one, we can look for data sources that match existing theories, right? Or methods, right? And AI and LLM methods, or ask what theories I could test with this data, with this computational method, with this tool that I have in hand, right? And this is a little bit creative, but it's also very promising in my eyes because we can do so many things. And at the same time, beyond testing theories, these data sources, these digital methods, computational methods, AI, LLMs, can also help with generating theories. So they can help us formulate new theories. And like the question is why. So new aspects of social life become measurable that they weren't measurable before. So this enables us to formulate something new about a specific aspect of human life, a new theory, or extend an old one, just because we have access to something that was not measurable before. And we can detect patterns in some new ways with AI and LLM especially, that we can now formulate new concepts and theories, right? And these two, testing and generating theories, is something we sometimes overlook when we speak about these methods. We focus too much on the method itself and what it can do, whereas in fact we should also be thinking about what it can tell us, what it can do, how we can use it for theory building. It's not something we should be forgetting. With that in mind, I would like to go to the ethical use of AI in academia. I mean, I had a section also about writing with AI and publishing with AI, and there are tons of tools out there right now for improving your academic writing. I assume majority of you guys in the call today, including me, we are not native English speakers, and that makes writing sometimes we are at a disadvantage sometimes when we write academic text that is science is being done in English, right? So we've been using proofreading tools forever. We've been paying people to do proofreading for us before we publish papers forever. AI and LLMs can help us do this potentially better, again at a fraction of a cost. Because there are now models that can do academic writing, that can help you with academic writing, that are specifically for academic purposes, tailored for fine-tuned for academic purposes. And they're out there. I had some slides, but I don't want to mention specific tools anymore. I mean, something we can talk, and it's a little bit beyond the scope of this workshop and the project anyway. But yeah, I'm here to ask questions if you have them. You can even just prompt your way to better texts. You can just by prompting an LLM. I'm sure you've done this. I've done text editing with ChatGPT or whatever. Just paste that text there, and you can ask questions about improving it in multiple ways. There are ways to do it better, but again, as I said, it's a bit beyond the scope. But I'm happy to answer any question about that. And then finally, there are also tools about publishing, AI-based tools about publishing. There are tools that transform papers into PowerPoint presentations. Some are pretty powerful. There are tools that can do mind maps, concept maps that are very nice, very helpful visualizations. So a couple of things people can do. In any case, I just want to finish with talking about ethical use of AI in academia, having all of this in mind that we discussed today. I mean, we've seen how someone could use AI in multiple stages of the academic process, right? From idea generation, literature review, collecting data, analyzing data, data science part aspects of the pipeline, but also writing and publishing, right? So all of these aspects are influenced currently as we speak by AI. People use AI to do all of this. The question is how we can do this ethically in academia. And the discussion is basically falls around integrity, honesty, and transparency. So when we do academic work, we need to be honest about what we're doing, how we did it. We need to be transparent about it so that people can. Yes.
Sorry, we don't see your screen.
No?
No.
Oh my God. Have I been talking all this time without sharing? Yes.
4 or 5 minutes.
I apologize for that. At least I didn't say anything very specific before without I wasn't looking at the slides anyway. So okay, so let's talk about ethical use of AI in academia again. So as I said, integrity, honesty, transparency are prerequisites for academic work. So you cannot be doing science without these three aspects. So AI and chatbots and LLMs are not there to replace your human judgment, your critical thinking, and also the creativity in the writing process, but also elsewhere. So this slide says writing process, but it's the entire academic process, right? And there is no easy way out of conducting proper science. So like if we look at these tools as ways to cheat in the sense of I'm not doing the amount of work that I'm supposed to do to produce an academic product. And by amount of work, that does not mean that I work too many hours inefficiently. These are tools that are meant to, and they should be used to increase efficiency, so reduce the amount of work we do, but at the same time, not take away certain aspects that human input is extremely important. Yeah, so in order to conduct proper science, the human input is there. We cannot be using these tools to cheat this process. There's no way to do that. And when we use these tools, we should be doing it complementary to, instead of substituting for our human expertise and our oversight. Our oversight is key here. These are just companions. They are here, they are assisting us, but ultimately we are the curators. We are responsible for that. And then finally, there's a big discussion right now about teaching, and I'm coming back to this debate we had initially. What you said, Dr. Sumey, is that as we speak right now, there are no good enough tools in terms of validity to check if someone is using AI and LLMs in writing or elsewhere. So we don't have the tools to do that. The tools that are meant to check if a document has been produced by AI is not valid enough. We cannot be sure that it's producing correct results. Someone might have written a text from their mind, and an AI checker tool might say that it's 90% AI. So we don't have the tools to do that right now. So the debate is, it's more important to be sure that the tools we have to check if someone used AI is valid than make sure that someone does not cheat. So if they want to cheat, they can cheat, basically, is what they're saying. So the important thing is that we have tools that are valid first, and then try to tackle cheating. Right now we don't, so we cannot enforce this. So there are three basically institutional approaches that some universities choose to go with. I'm not entirely sure about Ibn Haldun in this case, or your organizations, your institutions, but basically there are three paths. Either they say no use of Gen AI is allowed at all. Either they say a defined use of Gen AI is allowed, some aspects only, or they say all use of generative AI is allowed. So these are the three pathways. There's no other way, right? My university currently is at number 3. So all use of generative AI is allowed. At SODAS, master's thesis students can use AI in whichever aspect of writing a project. And what we are trying to do now as academics is trying to teach students how to use AI productively, maintaining integrity and transparency and replicability of science, right? We are also trying to incorporate the use of AI in exams as well. We are trying to to show students ways of using AI to produce different outputs for the specific exam they're writing, right? Because, I mean, Gen AI tools are omnipresent. It's really hard to make sure that someone is not going to use it. One way is maybe, have exam centers with no internet access, and make sure that way that there is a barrier between the exam and the students. But then depending on the kind of exam you're having, I mean, it's really hard to avoid someone using Gen AI to write text anyway nowadays. So it's kind of complicated. So yeah, for my university, the rule is transparency instead of AI detection tools. So we ask students to tell us what they used, how they used it, when they used it, in which parts of the text for their exams. Journals themselves have their own AI tools rules, right? For how you can use Gen AI for writing, and also generally the academic process of writing a paper and producing science. All major publishing houses have their own rules, and you can go check depending on what you do. But basically, the rules of the game is very simple: disclosure, disclosure, disclosure. So you need to specify what tool you used, how you used it, what model specification it was, the prompts you used, etc. Right? All of this stuff that we discussed. So you need to be open and upfront about it. Text editing is completely allowed, but without altering findings, of course. So you cannot alter figures, plots, wording. Those need to be your own product. They cannot be product of AI. Or you cannot also change the conclusions so that the original output, your text, is changing just by making some sentence in the conclusion sound more provocative, or sound like a more significant finding that it is, for example. Also, for these journals, LLMs do not fulfill the authorship criteria. That means that they cannot be, so you are the sole author of a paper, so you cannot have an LLM write parts of your text and then say, okay, this is the LLM writing it, it's not my fault. No, it is your fault. It's still you that wrote it. So you cannot blame, let's say, the LLM for something. Obviously, it's a big no-no for the peer review process. So the blind reviewers cannot review papers using AI. I mean, they're forbidden to do so. I'm not sure if they're not. That's another research question, perhaps, for someone like you to test. And also, you cannot respond to peer review letters using AI. General things to do: set clear goals and objectives for the tool you're using. Don't change them as you go. So start thinking about how you will use a tool for your research pipeline. Make sure what you expect and how to use it. Use multiple tools to verify your suggestions and accuracy. Revise what you get from these models based on your human judgment and your critical thinking. That's so crucial. and continuously evaluate this process, especially in writing. So obviously the don'ts are kind of obvious, but I have to say them. So don't present AI generated content as entirely your own without disclosure. Don't use AI to fabricate data, citations, or research findings. I mean, that's obvious, but it's still there. Don't rely on AI for critical thinking, for argumentation, or original contribution. This is still something that the model can potentially offer some thoughts or suggestions or stuff like that, but it's still you are still the scientist. They're never going to be as good. I mean, they're not as good as we are at that right now. Maybe at some point they will get, but for now they're not. Don't try to use AI to circumvent the learning and skill building process. It's much more important to learn a little bit about Python while making some mistakes, instead of just using an AI tool to build the entire thing for you very quickly. It's also about you interacting a little bit with the process and learning skill building. As we said, confidential and proprietary research is not safe, so don't use it with AI without permission. Speak to your partners, especially when you have like copyright data. Also, when we use AI, we're not entirely sure we're not violating copyright laws, because some of these models, especially OpenAI and ChatGPT, notoriously has trained its models on data they got from people without their permission. And we need to be aware of that too. And obviously, don't assume that AI-generated content is accurate, unbiased, or neutral. We've said this, but it's really important to keep in mind these models are not neutral or unbiased. And with that, I'm gonna stop. I mean, there are the EU living guidelines about Gen AI in research. I mean, you can check them. I'm not entirely sure they are pertinent to you guys, but I mean, they are there. And I think we have a little bit of time for some Q&A, if you agree, Sumaya.